One very straightforward change or upgrade you can do to your bicycle to make cycling more engaging is to change the chain ring or chain rings, whatever the case be, on your bicycle. In this video I'm going to explain why you would do such a thing in the first place and what's involved in a chain ring replacement or upgrade job to ensure you get the right part that suits your need and fits your bicycle at the same time. So the considerations are a little bit geometric and a little bit mathematical, but they are not rocket science. I will also show you the tools that are involved and the skills that are needed for mounting and replacing your chain rings. At the moment, I'm in the middle of cleaning and checking my chain rings. I have removed the mounting bolts, so the chain rings are just dangling here on the crank arm. Every so often, about 3 times a year or so, I take both chain rings off the crank arm and check them. I check out their geometry, make sure there's nothing chipped, bent, missing, cracked, broken, whatever. I put them on a piece of glass, float glass, to make sure they actually lie flat, and they could be cleaned while in place with a rag and some solvent or whatever, but I like to actually hold the piece, lift the piece. I can feel if there's any crack in it, or just by vibration, whatever. You can shift the components the way and handle the components. You can check out the wear in the gullets here, there where the chain engages. You can check the tooth profile out up close, lift it close to the light where you can see it. You can actually see on this side of the teeth where my nail is. This is where, when you're pedaling and you exert a force, this is the side here where chain ring wear is going to show up, because the teeth are pulled in this direction. This one is rotating forward this direction. So I do check out my chain rings, their tooth profile, really thoroughly after cleanup. So that's why they are taken off about 3 times a year. Let's start with the number of teeth. I have 2 sets of chain rings here. This is my old set, this is my new set. This is how math works. Whether you have 1, 2 or 3 chain rings, the more teeth you have, the faster you go, if you have the legs to power you actually through it. So more teeth on the chain ring, more speed, okay? Fewer teeth on the chain ring, less speed, but with less speed you can climb more. So I wanted both. I wanted both to go faster on flat roads with my big chain ring, and I wanted to climb a little slower, exerting more torque and climbing with less pain and more speed. So I replaced my original big chain ring with one that has more teeth. I don't know, 2 or 3 more teeth on the large chain ring, and on the small chain ring I have 2 or 3 teeth fewer on the small chain ring. So I'm both going slower up the mountain where I need to exert more torque to get going, and I can also go faster downhill and on the flats. That's number of teeth consideration. Another consideration is number of bolts mounting the chain ring. It looks very obvious when the component is in front of you, but if you go to the store and you forget it, it's dictated by what type of or what brand of crank arm you have on your bicycle. So if it's a 5-bolt pattern, you're gonna need obviously 5 bolts, but other configurations also exist. 5, 4 and 3 bolt mounting patterns exist, so just a heads up, make sure you get the right part. Now, it's not enough to know that how many teeth you need and how many bolts you have. You also need to consider one more thing here. The bolts that mount the chain ring or chain rings lie on a circle. I know you can make a pentagon out of this, but you can also put a circle through it that goes through the center of the bolt holes on the crank arm spurs here. Okay, this circle has a diameter. This is your bolt circle diameter. In this case, the bolt circle diameter is visibly printed by the manufacturer plainly. That it's 110 millimeters. I have another video how to come up with this number, or by taking a simple measurement, ideally with a vernier caliper, not with a ruler, between two adjacent holes like so, and that's gonna get you the diameter. If you measure between two opposite holes, that's not gonna be the diameter. The diameter is a little more than that. The diameter has to go through the center of the circle, so the corners of a pentagon, that's not gonna work. That's not gonna be your bolt circle diameter. This bolt circle diameter issue is indicated here on this part of the packaging, so I needed to make sure I have 5 bolts and a 110 millimeter BCD, bolt circle diameter. So these it's not possible to eyeball 104 or 130. I needed a measurement, so I'm gonna share that in this video's description box below. I'll have a link for it. Another consideration, so that's number of teeth, number of bolts, and bolt circle diameter, 3 down. The next two concepts are geometric flatness, parallelism, and distance. Let's talk about flatness. So besides putting the chainring occasionally on a flat piece of float glass and make sure it's not warped, not out of flat, both of them of course, besides that, they also need to mount flat. What that means is that on the spurs here, on the crank arm, on the shoulder here, and on the back side, if there's any kind of dirt here compacted that interferes with the mounting of the component, if these spurs on the chainring do not lie flat in this position here because there is some crud in there, then what's going to happen is the steel bolts, which are stronger than the aluminum or aluminum depending on your market, chain rings, what's going to happen and what can happen is that these spurs here, let me show you how this works. I'm trying to push it sideways to flex it or bend it. I don't know if it's visible, but it does bend a bit. If this bends a bit, in, that's likely to push these 3 teeth out. I hope that makes sense. This bends in, these go out, and if these 3 or 5 teeth are pushed out a little bit, then the chain is not going to run straight. So flatness or lack of it leads to straightness or lack of it, and if you have 2 chain rings, they need to be parallel with each other, so both need to be mounted stress-free without any of these small bending forces on account of accumulated dirt here, so that these sideways forces don't pull the teeth out of straight. They do so. I know this because I mounted them on some cruddy surfaces previously and was wondering why shifting was imprecise, and as soon as you look down and rotate it, once it's mounted, and just spin it, if you look down from above you can see if it's out of straight. The teeth on the chainring need to travel in a straight line. I can't really do it freehand. It has to be mounted fixed, and you have to look at it without moving your head anywhere. So flatness and straightness, and bend stress free mounting. In terms of mounting, since we're at it, torque wrench is necessary or highly recommended, so that the bolt, you're not stripping out the not stripping the thread out of the bolt, and and they are not loose either. For removal only, just to speed up the process, I use a drill, but it needs to be cranked first. It doesn't have too many threads, so it doesn't need too many rotations to take it off. So the drill is only here for quick removal, not for mounting. The thread pitch on this is a fine thread pitch. That means it's strong, but it also means that you can start it cross-threaded. I'm just exaggerating it. If it's cross-threaded, it's got the mounting tabs might be bent. Instead of exerting a force all around that round recess there where the bolt head goes through, the mounting force for the from the bolt is going to be bending this tab slightly, making the teeth misaligned. So make sure you don't cross thread the bolts. The bolt also has, or the nut actually, the nut has a, let me just start it, there we go. So that's what I mean, fine pitch thread. Has a serrated nut, and these serrations are on the inside edge there. This is a steel bolt, and these serrations are supposed to put a permanent dimple in the softer aluminum or aluminium smaller chain ring, or the outside surface of your single chain ring. By the outside I mean that one closer to the frame. So maybe not outside, maybe inside, so this back side, okay? When these serrations displace some of this aluminum, it's gonna look a little bit dimpled like that, but that's fine. That's how this fastener was designed to work. So it doesn't need to be held by two wrenches when it's tightened. It's gonna bite into the aluminum enough to stop it from spinning, but just in case it does, you have a slot in it. You can put a screwdriver into it and hold it that way as well when you tighten the bolt. Again, tighten, torque wrench. Initially, of course, you can just, you can just spin it in, and I strongly recommend just hand spinning like so all the way, because you can feel with a hand tool, either just a socket like this or with the L-shaped Allen key or hex key. This is a 5mm, there is a 5 upside down, 5mm Allen key. Just spin it like this, fairly straightforward. One other thing that concerns mounting is, take a look at the back side of the smaller chainring here. There is a lip here, that's fine, and there's a recess here on this side. Well, it's also fine, but this recess, the depth of this recess here is critical. So this needs to be clean to make sure that the spurs on the crank arm on the back side fully engage and interlock with the recesses on the smaller chainring. And the recesses are slightly oversized, so there's a slight side to side play on it, and you can hear it a little bit like so. It's supposed to do that. The bolt is going to center it, or the nut, because the nut is larger. So when the nut goes through the chainring, it's going to center it, and that's going to stop it. But there should be a play before the nuts go into it, and the edges of the recess should lock the two components together like this. This is not only for power transfer and making it stronger, but it's also critical for, so we discussed flatness, straightness, and parallelism. Now we're going to discuss the distance between the two products. So the center line of the small chainring and the center line of the large chainring need to match. The thickness of your chain, how these two are designed to work, is this. The thickness of this spur here between the large chainring and the small chainring minus the depth of the recess that interlocks the small one, that distance with the thickness of the spur between the two of them, that distance should match the thickness of your chain. I hope that makes sense. And of course, it's once I pull the small chain ring out to the front, it's much less spectacular and it's difficult to hold the two of them together, but you kind of get the idea. And of course I don't have the spur between the two of them, but this is the center to center distance that's critical for shifting your chain. Oh, in the process of cleaning every component of my drivetrain, the chain also went through 5 or 6 baths of lacquer thinner cleaning, so it's absolutely clean. Same for the chain rings, same for, by the way, my cassette set on the rear wheel. So that's what I have in mind for cleaning everything. The parallelism and the distance between the two of them is critical, and so this distance between the two chain rings is affected by the cleanliness of this recess here on the small chain ring, okay, because the small recess needs to engage with the back side of the spurs. I hope that makes sense for interlocking, the distance, parallelism, straightness, flatness, teeth number, bolt number, and bolt center diameter. It's geometric, there's no two ways about it. Last mounting item is this steel boss here, or dowel in the chainring. This is a feature, there isn't a matching one in the small one. The steel pin should go on here just behind the crank arm, because that prevents the chain, just in case of overshifting, just in case the derailleur is set a little imprecisely, so the chain doesn't fall in here between the crank arm and the chain ring, because if it does, it's just miserable to take it out from there. So that's why this pin needs to be directly behind the crank arm. So it is possible to mount the small chain ring backwards. This is the nice way, with the recesses interlocking with the backside. It's possible to put it on this way, but then the distances between the two of them won't work and the shifting will be not precise enough. Not by much, but it's gonna be just reason for the chain to fall off. Okay. There is one other variant of this nut that I can show you on a 1980s bicycle, but I want to point out the fact that this setup works with a narrow gauge chain, which means if I switch on this digital vernier caliper and measure the chain at the pins somewhere, it's about 5.7 millimeters. So this is a narrow gauge chain, and the thickness of the chain works with the distance of the chain rings. And behind you here I have a 1980s bicycle, and this one has a thick chain, an older chain that works with a 6-speed cassette at the rear here. And if I can do a measurement and rotate it enough, not really, but you can kind of see it's 7.2 millimeters. It's the wider chain, not 5.6. Now, the wider chain means that these two chain rings have to be spaced further apart. Very straightforward. The manufacturer needs to make the spurs at a precise thickness to make sure that these two are offset by the chain's thickness. Yeah, but sometimes the manufacturing process, it needs a few shims. So that's what we have here. This is a shim. This mounting method has shims as well. Let me show you one. If I take you off the tripod, you can see the edge of a shim just underneath the outer chain ring. I'm going to take that shim out, and with the shims on older bicycles, like this one is from the 1980s, the shims need to be, it doesn't matter if they are underneath the large chain ring or underneath the small chain ring, typically they go underneath the small chainring, but I'm experimenting with it now, so I put it underneath the large chainring. As long as they are consistently underneath the same, on the same side of the spur, on the crank spur, so not out of the five, if 3 of them are on the outside and 2 of them are on the inside, they're gonna work. It's gonna make the chain rings be bent. So if I take one, yeah, sorry, this is not a good removal tool. I need to break it a little bit. Then there, that's what I mean by removal. Push the nut out on the other side, and almost there. There, so that's the nut and that's the bolt, and the shim is still in between the 2 of them. So if I flex them apart, the shim comes out. This is how the shim looks like. It's about 1 millimeter thick. So without this shim, maybe not 1 millimeter, maybe 0.7, okay, 0.8. So without this shim, the 2 chain rings will be too close together, and they really don't matter much which one you want to shim further out or whatever. I kind of wanted to shim the larger one further out here, and that has to do with cross chaining. Don't worry about it, different concept, but I wanted to make better use of the faster or the smaller sprocket here, and so that's why I shimmed the larger one further out this way, if that makes sense. So this one, these chain rings mount with this shim, don't lose them. And these ones, the newer ones with the narrow gauge chain, they don't need any kind of shims, so don't be looking for one. They will just work without shims for the narrow gauge modern chains. So that's basically all the geometric involvement or complexity, and that's the tools and that's the skills that that are involved and that I have here. This is your powertrain. It needs to be mounted fairly accurately and fairly precisely in order to get the most out of it, and to get back to my original point, to make cycling more enjoyable, this needs to be really precisely mounted. So thank you very much for watching, and please check out my links about gear train calculation as well as bolt circle diameter calculation. It's gonna be in the links below the video. Thank you. Have fun riding.